sure it's right. Okay. All right, girls. Any questions on the first page? Any hints needed on the first page? Okay, I'm going to leave the first page then. Any hints or questions on the second page?
Actually, sorry, could you go back to the first page?
First page, yep. Let me close the door so it's nice and quiet. Okay, which one do you need a hint on?
Can you just like explain the first one?
First one. Well, here's the hint. The hint is there's a certain angle. How about that? That you could have a non-zero impulse. The hint is it's a certain angle that the force is applied, an angle from the displacement. That's all I'm going to give you on that first one.
Okay, thank you.
Okay. Any questions on 2 or 3? Hints on 2 or 3?
Just 3. Not really how to do it. Just a question about like what it's asking. So
there are 2 of these systems that actually have the same acceleration. That's all.
So there's only one pair of 2 systems, or are there 2 pairs?
Well, it looks like there's. Did you find 2 pairs? Because I have 2 blanks.
Yeah,
Did you find
2 pairs.
Yeah, so maybe, I'm sorry, I actually, yeah, these, like, yeah, maybe I didn't do a good job of really explaining that. There are 2 pairs, there are 2 answers to this question, yeah. There are 2 systems.
Thank you.
Okay. All right, any questions on 4? 4 is a very interesting one. 4 is a very interesting one. Okay, no questions on 4. How about 5? Any questions, any hints needed on 5?
Could you give a hint for this one?
Okay, you got 2, let's see, 2 projectiles launched at an angle, one at 60 and one at 30. Now, so one is right, you get this concept of somebody saying some right things and another person saying some wrong things. What, if anything, is wrong about the student's statement? If something's wrong, okay, what's wrong? Position in the same place. Projectile is 6 million longer than the 30. It has more time to accelerate. Will strike the ground at higher speed than the. Okay, so there really are 2 statements that 60 will be in the air longer than 30, since it has more time to accelerate. So that's 2 statements right there. That it has more time. Let me see. What could I give you? So one of the statements is both the projectiles land at the same place. Projectile launch at 60 will be in the air longer than 30. So, I don't know if there's a hint that I give you. Let's see. You're gonna break it down. Do you get the concept? Like one of the statements here. That this is a statement. This is a statement. 60 will be in the air longer. That's a statement. Another statement that says more time to accelerate, will strike the ground at a higher speed. All right, I'll give you a hint on this. Yes, the hint is the conservation of energy. That's the hint I can give you this one. The conservation of energy. 2 projectiles launched at the speed. That's my hint. Okay, I don't want to give you answers. I'm going to give you a hint. They launched at the same speed. Yeah, that's the hint I can give you. Conservation of energy. Where because there's no friction in this problem. That's the best I can do with you on that one. That's not going to give you all the answers, but it'll help you get one of the parts. That's right or wrong, okay? And I'll give you one more hint. If 2 launch angles are the same angular distance from 45, they have the same horizontal displacement. If 2 launch angles are the same distance from 45, they're going to have the same horizontal displacement. Is that even part of this question? Let me see. Maybe that's not. Let me see. Oh, yes, that is part of this. Okay, yeah. if two launch angles have the same angular distance from 45, they're going to have the same, they can hit the same horizontal displacement. There's my 2 tips on that one. Any cool? I'm not going to give you anything on this one. You should be able to get, most people do get that one. Any questions on 7? Any hints or tips needed on 7?
Wait, which one you said you wouldn't give us like? Number 6?
6.
Okay.
6. This is, you know, can I give us, maybe I can, let me see the, so we're going to place the felt, so spend the least time. Well, maybe I can give you. You're going to spend the least time on the table if your average velocity is greater, right? You know what I mean? That's my hint on that one. You're going to spend, if you're going across the table with friction, you're going to spend the smaller, least time on the table if you in a setup where your average velocity is the greatest, the least time. Because you're going to, you know, the greater the average velocity, the quicker you'll take to get to the other side. I don't know if there's any tips I can really give you on this. Nah, that's pretty basic. You should be able to get this stuff. I'll give you a tip. No, area underneath equals displacement. There are positive and negative areas here. Be careful. Okay. I'll give you a tip on that. That's my tip on that one. I think you'll knock that out of the ballpark. How about 8? Okay. Okay.
We didn't have to label the axes, but like.
Yeah, you don't really know. No, you can't. And that's such a typical thing that an AP would do because it's really trying to stay away from the math. But I think it's clear to you, aren't these 2 shapes exactly equal but opposite? So you really don't know these numbers, so you can't. But you know what I mean?
If you made up numbers, but that would be wrong to just.
That's a nice strategy. That's a real nice strategy. I like that.
Wait,
that's a lot of people do. Very good. Good thinking.
Wait, so it's okay to make up numbers?
Yeah. Yes. That's very good thinking.
That's in the other graphs because that's what I did.
Yeah, that's very good thinking there, kiddo.
Okay.
Very good thinking. That's a good test taking strategy. This one's yeah, without mathematical computations. Okay. This one's a tough. I would just leave this as a super challenge. An object being lowered at a chord that is decreasing. I would, yeah, do the free body diagram is going to help you a lot. You know, if you're, how about the hint on 9? If you're lowering, but you're going down, but your speed is decreasing, well, which force is going to be the bigger of the 2? If you go, is it the up force or the down force? That's the hint on 9. Okay. Yeah, if you're slowing down as you're going down, one of your 2 forces, which your tension and your weight, one of them, think about that. If you're slowing down and you're going down, how's that possible? One of the 2 forces is going to be, which force would have to be bigger? Well, that's essentially the question anyways. Okay, that's pretty basic. That's pretty basic stuff. That's not fancy stuff. Right? I mean, do you need any hint on that? That's pretty basic, right? Changing direction. Anybody need any help on 10? Okay, I'll leave 10, 11. I didn't mean to insult you if you found it tough, but I think that's kind of basic, you know? Get that over there. I would draw a picture on that one and maybe start doing some calculations. Prove that this object must be read. Now, show, you know, discuss it with words and maybe numbers and calculations, okay? Draw the picture. Okay. 12. 12. Anybody need help on 12?
I just have a question about part C.
Well, first of all, let me make sure you know this because This is a classic mistake. Do the free body diagram. Then I would also do the pseudo free body diagram. What's that? You do the free body diagram without components, but I think in a separate paper, do the pseudo free body diagram that does have components for yourself to think about this. And I think a lot of people think that the acceleration is actually the same on these pictures. It's not. One has more acceleration. And remember, in physics, negative, negative is not bigger than positive, so I want you to get that, and negative acceleration is not smaller than positive. Be careful, these accelerations are not the same. Now you want to talk about C? Make sure to compare. Comparing, comparing the magnitude and the direction. That's what comparing does. Just don't talk about the magnitude. You should invest in the state without using mathematical calculations. Okay. Is that you, Kim? Did you have a question on C?
Yeah, I understood that we had to do a statement, and I did that. But just, do we have to do anything with the A equals at the bottom? Because like.
Oh yeah. It's first without the calculations, and then I would really like you to show me the math after you do. Okay.
Wait.
So you can do the math, and then you actually find out how do you do that, because you got friction forces on this thing, and you've got, what's the other force? Here's another hint. Basically, on both these pictures, you have two forces. Now they're different directions, but you've got the mg sine theta, and you got the friction. And now you don't have any numbers, but you can call it, mg sine theta, right? You got friction, you could just call it F.
Wait, so do you want us to solve for A?
Yeah, yes. So do it without first. So it's kind of like without calculations. Kind of like what the AD sometimes will do. Do it first without, and then do it. Then give you the math later. Okay.
So basically,
so you do the calculations here, and then you could do the answer here. Like do the A equals. I don't know why I have it. I don't really actually know why I have it down here again. Because you really can't get, as you probably already know, there are no masses, no angles, but you can put things in terms of theta and okay. So
I did for C, I just wrote like a few sentences under each one because it says without calculation.
For each one over here.
Yeah.
Now, did you talk about are they the same or the different? I would suggest, actually, your sake, can I just tell you, for you, it would be smart if you actually did the A equals is not very difficult. There are two competing forces. I've already told you. Now they go in different directions on both pictures. And remember, here's the other thing, the shove, don't include the shove, because the shove was done some time ago and is no longer playing a role in our picture. But you've got mg sine theta, you've got, what's that, mg cosine theta mu, and they're going, each picture though, they're going in different directions. One sliding up, one sliding down. Okay? So I'm sorry about this. I did kind of make this a little ambiguous. I'm sorry about this. I want to know this answer and this answer, and I guess this is where I wanted to do the explanation right down here. This was actually for you. This would help you. I was concerned you would make a mistake. I would suggest that you do this for you. It'll help you think and get this answer. So, this is an elevator problem.
Oh wait, so number 12, I did write like on the bottom the symbols. Like I put mg sine theta. I just like
good. Mg and mu, mg cosine theta.
Yeah, so
You all good. Yeah.
I'm good.
And I'll say it again. A lot of people looking casually at these two pictures say, "Oh, they're the same exact. I mean, it's the same box." No, be careful. They're not The accelerations are not the same. That's my hint to you, is they are not the same. As maybe you first look at it, I think, oh, it's the same. Actually, they're different. So I'm giving you that already. Okay. This one's very interesting. You can do the accelerating up. Now, this is not hard. Accelerating down. You're accelerating down would mean the down force is greater than the up force, right? Accelerating up means the up force is greater than down. This one's not bad, right? So you have, your two forces on that. It's actually mentioned. This one's a nice little, I'm going to leave this as a real, this is quite a challenge. I'm just going to leave that one alone. Any hints on any of these? Any hints needed on any of these? I'm going to label these. Anything that kind of threw you off? I don't think this is too bad, right? This one wasn't too bad.
Mr. Mangiapane, when are we gonna go over the tip sheet? Like at the end of the week?
Which sheet? Oh, the tip sheet for the test. That's towards the towards the end of the week.
Okay.
I want to make that tip sheet better because after I've made the test, so I'm going to make it better, and
Okay.
that's something I got to do soon to make the test, and then I'll make the tip sheet better, and then we'll go over it. We'll have to go over it maybe one night. This maybe Thursday night.
The test is Monday, right?
What's that?
The test is Monday, right?
Yeah.
All right.
It was really going to be this week. So all good on this one over here? All good? Some of these are pretty basic, I think, like this one over here. Should be pretty basic. I think you know about the acceleration. Okay.
Sorry, 13, for part B.
Yeah.
So you literally just want us to put it in the terms of the variables.
Let's see. We talk about 14?
No, 13.
13. Yeah, put in terms of the call the mass of the this one here you get the normal, the mg, put the n because your answer actually, what I believe this answer actually turns out to be. You can actually get it. This simplifies and you can actually get a value in terms of g. I think you do. I haven't looked at this in a while.
Yeah, the acceleration is in terms of g.
Is that what I asked you for?
Yeah, because
Yeah. Yeah, don't say anymore. But I think the acceleration turns out to be something in terms of g. Let me admit, Angela. Hi, Angela. I'm recording this, Angela. So anything you missed, you'll be able to see. I'll send that out. Let me get back to my. Whoops. Where are you? Right here. 16. Which impulse is the least? Justify your answer without using calculations. Why don't you get out the impulse equation? J equals ft equals m delta v. That's all you got to work with anyway. So that's that. Just use the equation to give you start to think. This one is like a question I think we've done before. So you have rank the forces. I would suggest you do box slice the right below. Choice of T. So just do sorry, right. Yeah, make a free body diagram. Draw a picture. It'll become obvious. You do that, and you do like if George exerts a force of T to the left, which is half of the force A. So there you go. You just call this one FA or something like that, and call. I guess that would be half FA, wouldn't it? And if you draw the picture, I think you get an answer. That is it. Angela, since you came a little late, is there anything in particular that you would like me to hit you?
Could you go over number 6, please? Because I really just don't understand what it's asking.
Okay. 6 over here, you've got a cart, rolls across a horizontal table, 2 meters in length. you have a piece of felt 1 meter long, and it's placed on a table, it slows the cart at a constant rate. So the cart, once it hits that felt, will slow down. Where on the table should the felt be placed so the cart crosses the table in the least amount of time? What's the hint? Well, obviously, to go across the table in the least amount of time, you want to create a scenario where the average velocity is going to be the greatest. True? If it's going to go across the table in the least amount of time, because we have changing velocities, it's the scenario that will make the average velocity the greatest. Now, do you put remember when the other hint, when the car hits that felt, is the only time the car it's going to slow down. Because well, let's see, obviously when it hits that car, it's going to slow down. Prior to that, there's no mention of it slowing down. Certainly, if it's rolling across a table, think about a car going across a felt. Obviously, it's going to slow down. It's going to be caused to slow down, but she even says at a constant rate. Imagine it, it really becomes very obvious. Do you put it in the first half? Do you put it in the middle? Do you put it in the second half? Where would you put it? Given the fact when that car hits that felt, it's going to slow down not only while it's on the felt, but when it leaves the felt, it's going to come off. Here's the other hand. It's going to come off that felt slower than it started and keep traveling. So use your common sense on that point. Kind of visualize it. I bet you, even without the physics, I bet you see it. Visualize each scenario. I bet you it becomes super obvious where you're going to put that felt. Okay? And I'll give you one more question. I'm going to send this up, girls, and send it over to you. And you can look at it again. Any other questions, Angela?
I'm just looking. I forget what number it is.
Or maybe did anybody else come a little later? And maybe you didn't hear the early part?
I had a question on number 3.
Okay. Oops.
Are there 2 answers for it?
Uh-oh, what am I doing? What? Let me get out of here. How did I get in here? Hold on. What did I do? Sorry, girls. I don't know what I just did. Why can't I get back to hold on. What do I do here? Not stop presenting. I want to get back to presenting to everyone. I can't get back to stop presenting. How did I get here? I want to get back. Can you girls hear me? Somehow I got away from my screen. Let me hide this. I'm a little lost here. Do I X this out? Oh, good. I think good. Okay. Go ahead and say it. Let me go back. Am I not recording anymore? Stop presenting.
We can hear you. You're fine.
What happened? What?
We're recording and we can still hear you.
Okay, good. All right, let me get back to, so who's that, Eliana? Who asked me that? Let me get back to this. Go ahead.
Liana, number 3, is there 2 answers for it? Because I had.
Let's see. Yeah, I didn't make that. Obviously, there are two pairs of solutions. Yeah, there are 2 letters that are actually like, is it A and B or like B and F? I don't know what it is, but like, yeah, there are 2 that have the same acceleration with each other. Like A and it might be A, B, and E. I don't know what it actually is.
Mine, I got 2 pairs of 2. So
You got 2 pairs? Did you find 2 pairs of this? Like the pairs are the same, and another 2 pairs are the same as each other.
yeah, well, I got 4 total numbers, and each one is paired with another one, like 2 pairs of 2 numbers.
Yeah, you found 2 pairs. Yeah. So all you have to do, you know what you do? You just take this, and what's the acceleration of this? Well, it's just 50 minus 10 is the net force. 40 divided by 6, right? A equals F. You get that? And so why don't you get all of the accelerations? You'll find there are 2 pairs that have the same there are two that have the same acceleration as each other. You know what I mean? 50 minus 10 divided by 6 would be this acceleration. 30 minus 10 divided by 4, you'll find two pairs that are the same answer. Okay? So that's it, girls. That's all I got for you. Because I already told the other class that I would do 7:30. I don't know why I did that, because I wasn't thinking. I'm going to also open it up at 7:30 if you want to join me again. Okay?
For
Have a
this one,
good-
I just
good
like
one.
for this one, I just solved for each of the 6, and then I just
Yeah, good. Good thinking. Did you do like 50 minus 10 divided by 6, right?
Yeah.
30, yeah, good. And you'll find, and you did find, right? Who's that, Julie talking?
Yeah.
And you found two pairs that have the same,
Yeah.
you know, you did good. It just goes to show you that it's not just the net force, but it's the net force and the mass that determines acceleration. I'm going to stop this now and